glance. So this lesson is 1.1, solving equations, and your EQ is how do you solve an equation in one variable, which means that we're looking at equations that have one variable in it, like it's an x that you're solving for, or an m, something like that. And this is review, so it's been a while. We had a nice long extended summer, early summer start. So we're going to go back and revisit how we solve equations, and we want to look at some vocabulary first. So equation is a mathematical sentence that uses an equal sign to show that two expressions are equivalent. And solution of an equation is a value for the variable that makes the equation true. Now, if we have an equation like 3x plus 5 equals 20, there's vocabulary to refer to different parts of the equation, and that's what this little diagram is showing us. So the entire thing, both expressions, both left and right hand expressions with the equal sign in the middle, the whole thing is called the equations. Equations have equal signs. Yes, so these are notes, and just to remind you guys, this is being recorded. I'm going to post the video link on our Week at a Glance just right after class today. So I don't want you to try and take notes while we're going through the slide. I just want you to pay attention and participate. Okay, there's going to be stuff for you to do on the slides where it's going to ask you questions and you're going to give me some feedback. So you can take notes later. It's best just to pay attention right now. Do the notes later. But it would be notes, yeah. A term. So the 3x right there, that is a term. It's the pieces of the equation that are added together. If you look at the 3x term, the x is the variable, it's the letter part, and the 3 is the coefficient. So it's the number that touches the letter. It touches the variable in that term. That's the coefficient. And if you happen to have a term like 5 where there is no variable, it's just a number, that is called a constant. 20 is also a constant. 5 and 20 are like terms. So terms that have the same variable part are like terms, and you can actually combine those. And if I wanted to solve this equation, I would do that. So let's see what you guys remember. You're going to toggle back over to that Pear Deck tab, and now I have a problem for you to do. So you can draw on the slide. You're going to solve 3x plus 5 equals 20. I want you to show me what you're doing in the box, and then in the big box, in the big white box, and then put your answer in the yellow box. All right, so I'll give you a few minutes to go in and do that. You're just going to have to draw with like a mouse if you're using one, or your touchpad. You could probably also type out what you're doing. That is another option for you. Okay, so you're going to toggle over to the Pear Deck slide, and you're going to solve that equation. Okay, if you're still sitting in the meet, please go to your Pear Deck slide, and I want you to participate. You have a text tool, you have a pencil tool, you could do a line.
Miss?
Yes.
Yesterday, I couldn't go in class, and I'm late because I had to get a new Chromebook. Mine broke. My last one.
Bummer. Okay. Did you do the warm-up yesterday?
The mouse pad wasn't working, so I couldn't do nothing.
Okay. Well, just do it today, and then I'll update attendance for you, okay?
All right, thank you.
Sure. So I see all kinds of different work happening. I see someone who's done the kind of like the box and wall method, if you remember hearing about that before, where you put a box around your variable and a wall coming down from your equal sign. Looks like some of us are using some inverse operations. I have some people that maybe did some mental math and they have their answer. Take a couple more minutes, so get something down. Do as much as you can, whatever you remember. I'm pretty impressed with some of your skill on writing with the pen tool. It looks really neat. I don't know if you're using like a touchpad screen or something, but looks good. I don't know if I've seen anyone use the text tool yet, which is an option for you. You can actually type out numbers and letters, and it'd be really, oh wait, here's someone who's using text. Yeah, that looks really nice. It's easy to read. It's probably easier for you to do too. Nice. Okay, so I'm going to go ahead and just share with you some of the things that people are writing. I think that's a thumbs up. That's great. So it looks like they're writing out kind of like their thought process. So they did 20 minus 5 and they got 15. 3x equals 15, and they know that 3 times 5 is 15. So x has to be 5, and then they put that in the box down there. And this is more like using mental math to figure it out, which this is correct. Right here, we jumped right to like some calculations and the answer. They put a box around their variable. Maybe they're going to do box and wall. Here's someone who typed it out. 3x plus 5 equals 20. 3x equals 20 minus 5. And then 3x equals 15. Looks like they're still kind of working on it, but they're off to a good start. So someone is doing a number line, I think. So here's when we're showing the inverse operations on both sides of the equal sign. So there's these rules when you solve an equation that whatever you do to one side of your equal sign, you can do whatever you want, but you have to make sure you do the same to both sides. That must have been Mauricio's thumbs up. And here the inverse operation, because we have addition of 5, we're going to subtract 5 on both sides, and then that's how this simplifies out over here, and we end up with x equals 5. This has a flow chart going, so you can see what's happening all the way to the answer. That's nice. Okay, so quite a few of you are remembering how to solve. This would be what we call a two-step equation, because there's two things happening to our variable. X is the variable. It's being multiplied by 3. And it has 5 being added to it as well. So it's a two-step equation because there's two operations that are occurring with that variable, which means there's two things you have to do to undo what's happening to it to solve it. And in 8th grade, you guys learned about one-step, two-step, multi-step. Okay, but with the topic of our notes, it is an equation in one variable. So it doesn't mean one step. It just means that there's only one variable we're solving for. Oh, now we have a happy guy. All right, so good. I'm happy we're remembering stuff. So these are some properties of equality, and what some of you guys were doing in there is this is more like formally what it's called that you're doing it. Addition property of equality. Okay, so if I add 3 to one side, I add 3 to the other side and still equal. So like if I started with 3 equals 3, I'm sorry, if I started with 2 equals 2 and I added 3 to both sides, no, I was right the first time. You're starting with 3 equals 3. I'm in this first number box. And then they're adding 2 to the left and they're adding 2 to the right, and then we end up with another true statement, 5 equals 5. It works with subtraction. So if you start with 7 equals 7 and you subtract 5 on the left, subtract 5 on the right, you still end up with a true equality, 2 equals 2. It works with multiplication. So if you start with 3 equals 3 and you multiply both sides, the left and the right, by 4, you end up with a true equation again, 12 equals 12. And it also works with division. So 15 equals 15. If I divide both sides by 3, then I end up with 5 equals 5. So that's just number examples in this column, but then you have the algebra column, which is more of a general way of representing what you're doing, okay? The restriction is on the last one for division. You're never allowed to divide by 0. Okay, don't forget that. Okay, so here's an example. Solve the equation by using properties of equality. And the properties of equality were the 4 that we just looked at. So my equation is 3x minus 2 equals 6. And using the addition property of equality, I can add 2 to both sides of the equation. So here, the way they're showing it is they're just keeping it all in a row, which is fine. And when some of you guys were working that out on that other slide, a lot of you write it, you know, on the next line down, but you're still doing it to both sides of the equation. So it is the same thing, even though it just looks slightly different. And so if I combine like terms, you end up with 3x equals 8. And now to use the division property of equality, we divide both sides by the same number, which is whatever is going to get the x by itself, and isolate our variable. So we choose to divide by 3. 3 divided by 3 is 1. 1x. Remember, when the coefficient is 1, 1x, you don't even write it. You can write it. It's not wrong to write it, but typically you don't see it there. And then 8 over 3 is the same as 8/3. All right. Your turn. So this is a drag the numbers to where they go type slide. So what you're going to do is go back to your pear deck slide. We have an equation. 1/2 z plus 4 equals 10. And on the first line, it says use the subtraction property of equality. So what should you subtract from both sides of the equation? You have some numbers down at the bottom. You have 4, 4, 6, and 6. You're going to drag the numbers into the 4 boxes where they go. Combine like terms, and then use the multiplication property of equality and multiply each side by 2. Okay, so drag the 2 4s and the 2 6s into those 4 empty boxes to where it will make sense. Okay, about another minute to do this. I see some people are working the other way around, so that's kind of an interesting tactic. They took the fact that my answer is 12, z equals 12, and then just working up, well, what would you multiply 2 by so that you get 12? It's a good idea. All right, I have 14 of 23 responses, about 20 more seconds. Wow, this person has a lot of numbers. So there might be a way to reset that so you don't have to have so many on your one screen. Oh, wow. Okay, never mind. That's funny. Yeah, no, this is just showing everybody's response on one slide. My bad. Okay, so this first little box, it looks like we got 4s here, and that is what you should have. You should have a 4 in this box. This is hard to see. This is not really the best way to do that. So can I drag my own? Will it let me do that? I don't know if it's going to. I could come over here. Let me just present like an individual slide of someone who did a good job. Okay. Sean, you did a great job. So if I come over to Sean's, Sean, go back to your pear deck slide. Oh yeah, now you created this weird like thing goes in forever. So if we subtract 4 from both sides, great. And then combining like terms, 10 minus 4 is 6. And then, you know, we simplify it all the way down to z equals 12. So this was a tough one to try to show everyone's work at the same time, but good job, Sean. All right. Let's go back to our Google Meet or to the presentation. All right, so we're going to solve an equation to determine the unknown quantity. So we have a word problem. We have a word problem about an ostrich and a kiwi. Kiwi, not the fruit, but the little bird that you see there with the long beak. An ostrich that is 108 inches tall is 20 inches taller than 4 times the height of a kiwi. What is the height of a kiwi in inches? So from this, we're going to create an equation, and then we're going to solve for it. So K is going to be the height of the little kiwi bird. And then coming back to the key information in the word problem, an ostrich is 108 inches tall. Okay? That is, when you see that word is, that's a clue that you have an equal sign. So 100 is 108 inches is, so 108 is by itself on one side. And then 20 inches taller than is like more than, which means to add 4 times, 4 multiplied by the height of the kiwi. The kiwi is the unknown, so that's where we set a variable equal to our unknown, and we come up with this equation. Let's see here real quick. You know, if I go forward, yes. All right, it's your turn. So here's our equation, just from the last slide. It's 108 equals 20 plus 4K. You're going to solve that equation and put your answer in the yellow box. So you should be back in your Pear Deck tab and working on solving that equation. I have 12 out of 23 responses. Which may mean that you've just started, so. Callie, nice work, you have the correct answer. Annabelle, nice work. You have the right answer as well. All right. Well, just to keep us kind of going with time here, because I do have one more thing that I want to show you today. You take a look. If we subtract 20 from both sides, we end up with 88 equals 4K. And then we divide both sides by 4, we end up with 22 being equal to K. So the height of the kiwi is 22 inches. All right, this completes our notes for today. And like I said, this video will be on our Week at a Glance later. I'll upload it to YouTube, so it's really easy to download. Last thing for today is if we come back to our Week at